Hey folks, Mrs. White here. As promised, today's lesson is just going to be practice of our last section that we were looking at. I know our last video was over an hour. I know that's rough, but I really wanted to try to stick those two 30-minute lessons together so that we could spend all day just working on solving to get really, really good at solving logarithms. So hopefully I'm going to try to make this video, we'll go slow on the first 4 examples because we're going to do 8 examples together. But we're going to speed up a lot on the last 4. So that way you're seeing as much as you need to see until you feel good, and then you can start practicing on your own. Today's classwork/homework is going to be a maze activity. I have it linked on Classroom, both paper and digitally, so you can print it if you want to. If not, I do have it as a Google Slides. Just so you know, 13 of the 15 problems will have to be solved. So if you end up doing 5 of them and magically you're at the end, you made a mistake. There has to be 13 problems total that you're solving to get to the exit. And again, it's linked on the Classroom. So we're going to start right off today by reviewing our 3 properties of logs. The first one is the product property. And just a refresher, the product property tells you if you have some log with some base and you have 2 things that are being multiplied together as your of piece, you could kind of expand those 2 out into addition problem where you have the log of whatever base and your first piece factor that you'd be multiplying by, and you add it to the log of that exact same base of the second factor. So you could take it like this and expand it into this, but more often or not, we're going to be simplifying things that are potentially addition problems, and you need to know you would multiply your 2 of pieces together, as long as they have that same base. The quotient property is like the exact opposite pretty much, because instead of looking at multiplying, we're going to be looking at dividing. So if we have some log with some base, and we have 2 pieces that are being divided, that could be rewritten as a log of that base with our numerator as our first of piece, and then being subtracted is the of piece of our denominator, okay? And the order of subtraction matters. It's really important that you do your numerator first and your denominator second. If you're coming from this and kind of making it smaller, so you're compressing it, make sure that your first piece that you would be subtracting from is your numerator, okay? When you read it left to right. The last property was called the power property. And the power property says if you have some log with some base and you have your of piece and that of piece is raised to an exponent, you can actually pull that exponent out front and make it a coefficient that's being multiplied by that log of the same base with that same of. Okay, and again, we might end up seeing things like this and have to pull the n down, but we also might have an n in front and know that, oh yeah, we could go and put that as an exponent right here. And now our bases are ready to be combined. And that's going to be a little bit more of what we see today. Now, there is something else we are going to see today that I want to talk quickly about. We'll spend more time really focusing in on it on Thursday, and that is what we call the common log. And I mentioned it very briefly last time that we looked at the video. The common log is just represented by the word log. If you look on a calculator, often you'll see a log button. And what that's implying for the common log is that you're doing a log with a base 10. Okay, so if you see log, I want you to just draw in that 10 today. And we'll spend more time talking about what the common log is and how it works when we get together next class. But some of our practice today is going to have that just common log or log base 10 as something we're working with, including our first example that we're going to start tackling right now. Okay? So let's start by looking right at, I got 8 examples, so these are the first 4. This worksheet is also linked on the Google Classroom, but it's arranged a little differently. So just if you want to follow along on that sheet, you can. If not, that's fine. I don't care. It's up to you, okay? I just wanted to make sure to provide that to you if you really wanted some practice that you could put in your notes. So let's take a look at this first problem. We have log with no base written here. And we have another log here with no base. I want to remind you that's our common log. We're going to write in little 10s. If you wanted to go through the whole sheet right now and every time they don't have a log base written, write in the 10, then you can feel free to do so because we're going to have to write them in at some point. Okay, so the common log is actually on this sheet a lot. This is 1, 2, 3, and 4. They're not organized like this on that worksheet though. Anyways, so let's start tackling this first problem. It is a solving because it has an equal sign. So I'm going to look right now and I see a log over here. I see 1 minus a log over here. And it feels weird because if I think back to yesterday, I want it to just be a log and a log on one side, or I want there to be a constant on one side and all my logs on the other side. This is not in that form. So what I want to do first, because I notice there is a constant, I want to move this log over to this side. And I do that just like I would do with anything else. It's a minus log base 10 of x, so I'm going to add log base 10 of x to both sides. Now, at this point, we can rewrite it. And for this first example, I will rewrite it. So it's going to be log base 10 of x minus 9 plus log base 10 of x equals 1. Now, the reason why I said I'll rewrite it this time is because in the future, I hope that when you see log with a base and a log with the same base and they're being added, you'll just say to yourself, oh, I need to multiply these two pieces together, because that's what we're going to do right now. So I'm going to take both of my ofs. Again, because they're being added, I'm going to multiply these two pieces together. This is a binomial, this is a mono, so I'm going to distribute it into both of those. And I end up with log base 10 of x times x, which is x squared, and negative 4 times x, which is negative 4x, equals, and then there's nothing to simplify here. So I'm going to take a quick look on the left-hand side. I'm going to say to myself, is there anything I can simplify here? Is there a coefficient I need to make a power? Is there anything else? And the answer is no. There's no coefficient, and there's only one log happening, so I can't simplify it any further. Now, at this point, once both sides are as simplified as they can be, there's two things that could happen. One thing that could happen is you have a log on one side and a constant on the other. Another thing that could happen, which you'll see in example 3 and example 4, is that you're going to have logs on both sides. Well, if you have logs on the both sides, they're just going to cancel each other out. Here, there's no log over here to cancel it with. So your strategy is to change it to exponential form. And this is where section 6.4 ties in, right? We take our log base, we raise it to this power, and we set it equal to this. So log base 10 of this equaling this becomes 10 to the first power equals x squared minus 4x. And hopefully at this point you're like, oh, Mrs. White, this is just a quadratic, right? Look, there's our x squared, there's our b term, here's our c term. We just got to move it over to this side. Now we have x squared minus 4x minus 10 equals 0, and we're ready to solve it. So I'm going to figure out what is it when I factor it. Okay, so it multiplies to be a times c, so 1 times negative 10, and adds to be our b value, which is negative 4. So if they multiply to be a negative, one's negative, one's positive. They have to add to be negative 4, so that means, excuse me, sorry about that. It means that my negative number has to be bigger. So what two numbers multiply to be negative 10 and add to be negative 4? Oh my goodness, I made a mistake the whole way through. You guys must have been screaming at me in your heads. This is not x minus 4. It's because I can't read my own writing. It's x minus 9. Right? X minus 9. So this is also a 9. So this is also a 9. And now my life gets a little bit easier because I was sweating for a second. I was like, nothing multiplies to be negative 10 and adds to be negative 4. So hopefully we're now all on the same page. Negative 10 times positive 1 will give me negative 10, and negative 10 plus 1 will give me negative 9. Because my a value is 1, I'm ready to put it into its factored form. It's going to be x minus 10 and x plus 1. I'm going to set each of those equal to 0, so I get positive 10 if I add 10, and then I'm going to get a negative 1 if I minus 1, minus 1. Remember, if I had set each piece equal to 0. So right now I have two answers. If you remember from last time, we have to check them because your of piece right here cannot be a negative. So I'm going to plug in 10 in both of them and make sure it's non-negative. I'm going to plug in negative 1 in each of them and make sure it's non-negative. Now, that means one could work, both could work, or potentially neither of them works, and I end up with a no solution. So let's try 10. 10 minus 9 is positive 1. That's good to go. If I plug a 10 right here, that's positive. That's good to go. 10 will definitely work. Next, let's try -1. -1 minus 9 is -10. That's a negative, won't work. -1 automatically can't be an answer, so my answer is B. Let's go down to our next one. Okay, we have log base 4 of x minus 7 plus, so I'm seeing a plus sign here, which means I'm going to multiply my ofs. Log base 4 of x minus 7 equals a constant. So the plus means I'm multiplying these two things together. And they're a binomial times another binomial, so it's going to be a little bit of work. I'm going to have to do x minus 7 times the x minus 7 from the other one. And then I can write it now as 1 log, right? I multiply my two ofs together, keep my log and my base the same. So 7 times 7 is x squared. Oh my goodness, x times x is x squared. X times -7 is -7x. But I'm going to have another -7x when I multiply those two. So together they'll be -14x. -7 times -7 is +49. Equals 1. This is as simplified as it can get. This side is as simplified as it can get. So right now I'm going to look. I have a log on only one side. That means I have to put it into exponential form. I'm going to do 4 to the first power equals this mess. Now 4 to the first power is just 4 equals, and then my of piece, x squared minus 14x plus 49. I got to keep going to solve this. I'm going to -4 minus 4. And I end up with 0 equals x squared minus 14x plus 45. It's a quadratic again. So I'm going to make my little factoring table. I'm going to ask myself what multiplies to be +45 but adds to be -14. Now if they multiply to be a positive but add to be a negative, they have to both be negative. And so I'm thinking 9 and 5, -9 and -5, add together to be -14, and they multiply to be 45. Perfect. So I'll put this in its factored form, x minus 9, x minus 5. Remember, that's not our solutions, and I have to set each of those equal to 0, and I get +9 and +5. So both of those could potentially be answers. Let's check. Actually, they can't because it's multiple choice and that's not an option. Let's just check anyways, though, okay? 9 minus 7 is 2. 9 minus 7 is 2. That's positive. 9 works. 5 minus 7 is -2. 5 minus 7 is -2. 5 will not work. My only solution is 9. Hopefully you feel okay about those right now. And you can see how our number properties or our log properties start kind of tying in here. Let's take a look at one a little different, okay? So here I have log base 10, log base 10, log base 10. I got logs all over the place, no constants. So my task now is to simplify this side, and then move things across or do whatever I need to afterwards. So this is log base 10 of 2x. There's no coefficient here. There's no adding or subtracting. There's nothing I can do. I'm just going to keep it as log base 10 of 2x. Again, it was the normal, what we call a common log, so it's a base 10. Over here, okay, I have log base 10 plus log base 10. When I add same bases, I need to multiply. So I'm going to send this 4 here and here. And I end up with log base 10 of 4 times x, 4x, and 4 times -3, and 12. Now, this is different than the other ones. Remember over here how we had a log equals a number, and here we had a log equals a number? Well, here we have a log equals a log. But what's good about this problem is that each of those logs are exactly the same, so they can cancel right out, okay, which is pretty cool. And we're left with just 2x equals 4x minus 12. And now it's just a normal solving problem. I can -4 minus 4 and get -2x equals -12. Divide by -2, divide by -2, and I get that x should equal +6. And I'm going to check this, okay? 2 times 6 is going to give me 12. That's good. Don't have to worry about plugging it in here. 6 minus 3, +3, totally going to work. 6 is my answer. My answer is B. Okay, so I actually really like when there's a log on both sides because it simplifies things. I just simplify both sides as much as possible, and then I just cancel out the bases and the logs. It works out great. So let's do another one like that. Look, log base 10, log, here's my equal sign, okay? I'm just gonna simplify both sides and then cancel out my logs. So these are being subtracted though. So this is a little bit trickier, okay? I'm going to have log base 10 minus log base 10. That means I'm gonna have, when I simplify it, log base 10 of 3 minus x, or 3 plus x, excuse me, over x minus 4. Ugh, not great looking at all, okay? Equals log base 10 of 4. This cannot be simplified. There's no number in front. There's no adding or subtracting. This is it. And this is it for this side. Now, you're like, I don't know what to do next. Slow down. If you have a log equals a log, you can cancel those out if they have the same bases. And this still is a little bit of work, but it's totally doable. 3 plus x over x minus 4 equals 4. You might say, I still don't know what to do, Mrs. White. Well, the dilemma is that we have a denominator here that's a mess, right? Well, to get rid of a divide by x minus 4, to take it out of the denominator, we would times by x minus 4, right? Those will cancel. Over here, I have to times by x minus 4. And I end up with, over here now, just being 3 plus x equals, boop, boop, 4x minus 16. Now this is where you start to like the way it looks, right? I'm going to minus x and get a 3x over here. I'll add 16, I'll get a 19 over here. Last step, divide 3, and I end up with positive 19 thirds. Boom, C is my answer. Okay, so this one was a little different. Not only do we have subtraction and have to set it up like a fraction, okay, but I had logs on both sides. Luckily, they canceled each other out, okay? When we have these fractions set up, it's going to be trickier. You're going to need to remember that you have to do this. To get rid of a divide by anything, you times by that on both sides to cancel it out, okay? If you're feeling good right now, feel free to skip over the next 4 problems. If you're not feeling great, feel free to follow along or pause it and try 1 or 2 on your own, okay? You do not have to go through this whole video. I promised it to be shorter and it's starting to feel long. So let's look at these last 4 problems. This first one won't be as bad. If I look, there's a log on one side and a constant on the other, which is one of my normal things to have to start thinking about, okay? I notice there's nothing to simplify here, so my task is to move it right into exponential form. So it's going to be 4 to the third equals 6x minus 2. So 4 to the third equals 6x minus 2. I didn't even have to use any properties here, okay? Now 4 to the third is 4 times 4 times 4, which is actually 64. I'm going to add 2, and I get 66 equals 6x. Divide by 6, I get that x equals 11. Now I should double check it, plugging it in here. 66 minus 2, oh yeah, heck yeah, that's going to definitely be positive. D is my answer. Let's go to 6. I'm going to look at 6 right now. It has logs, and it has a log here. So at some point, they're going to cancel out. And it's using the common log, so I'm going to write in my little 10s right here, right now. So these are being subtracted, which means I'm going to do this divided by this as my combined logarithm. So I'm going to have log base 10 of numerator, x plus 10, over denominator, x plus 4, equals, and then lastly, I have log base 10 of x, which I can't simplify. However, I'm loving it because I have log base 10 and log base 10, which means that I'm left with this equals x. Now, just like in this previous problem over here, I'm going to get rid of that denominator first by timesing it to both sides. So that's what I'm going to do to start tackling this problem. Okay, I'm going to times by x plus 4, and I'm going to times by x plus 4. Those cancel. I'm left with x plus 10 equals x times x plus 4 instead of just writing x times x plus 4, I'm going to distribute it through and get x squared plus 4x. Right now, I hope, right when stuff like this happens, that you start realizing, oh, it's going to end up being a quadratic. Even when I move these over here, I'm still going to have that x squared. So I'm going to minus x, and I'm going to minus this 10. And I end up with 0 equals x squared plus 3x minus 10. Now I'm going to check for factoring. So it multiplies to be negative 10 and adds to be positive 3. Well, that's going to be positive 5 and negative 2, right? Because they add to be that positive 3. So I'll put it right into its factored form. X plus 5, x minus 2. So my two answers are that x could be negative 5 if I set that equal to 0, and x could be positive 2. So I'm going to check these, okay? Because it could be both of them. It could be just this one. It could be just this one. It could be neither of them. So negative 5 plus 10 is 5. Good to go there. Negative 5 plus 4 is negative 1. It will not work. Won't work. Now I'll try 2. 2 plus 10 is 12. 2 plus 4 is 6. A 2 here. All of those were positives. That means my only solution is going to be 2. I have 2 problems left. Let's take a look. Draw my little line here. I notice I have 2 logs being added, and I have a constant over here. Okay, so at some point I'm anticipating the logs aren't going to cancel like they did here. I'm going to have to put it in its exponential form. So I'm going to start by simplifying over here. I'll have log base 4 of, I got to do these. I have to multiply these 2 together. So I'm going to have x plus 4 times x minus 4. This, I'm noticing right now, is what happens when we have a difference of squares. So I already know what the answer is going to be, but we'll go through it anyways. X squared minus 4x, plus 4x minus 16. And our little middle terms just canceled, and we left with x squared minus 16. See, difference of squares, told ya, equals 1. So a logarithm equals a constant. My strategy, remember, you have to stop here and identify, what do I do now? Oh, I'm going to rewrite it in exponential form. 4 to the first power equals this. So 4 to the first power is just 4, equals x squared minus 16. I'm going to add 4. I'm going to add 4. Oh, just kidding. I'm going to minus 4. I'm going to minus 4. And I end up with 0 equals x squared, these are same sign, add and keep, minus 20. So I'd be asking myself what multiplies to be, because it's a quadratic still, what multiplies to be negative 20 and adds to be 0, and you're not going to think of anything. In fact, we don't use factoring as a strategy when we only have 2 pieces. In this case, even though I know I moved everything over here, because I only have an x squared and no b term, I'm actually going to move my constant over and then square root it. Okay, so I'm going to add 20. I have x squared. There's no b term, and that's why I can do this. I'm going to square root to cancel. And now I'm going to solve or simplify this square root of 20. Okay, so the square root of 20, I'm going to ask myself, is there a perfect square in that? And there is. It can be divided by 4, which is a perfect square, and 5. So the square root of 4 is 2, and the square root of 5 is just a mess. Okay, so plus or minus, because we're solving a quadratic, so we have to have 2 answers, plus or minus 2 root 5. If you were curious, you could also grab a calculator, because we're going to have to check this. If I do the square root of 20, so let me just type that in real quick. Square root of 20, I get 4.47. So if I come up here, I'll put approximately 4.47, remembering both the positive and negative. If I put a positive 4.47 here, it's going to be positive 8.47. If I put a positive 4.47 here, the 4 will get subtracted off, but I'll still be left with a positive 0.47. So the positive version of this works right now. So positive 2 root 5 is good to go. Now I need to check the negative 2 root 5. So that means it's going to be the negative 4.47. Well, negative 4.47 and a positive 4 is going to be negative 0.47. Can't have it, which means the negative version of each of these will not work. And our answer is positive 2 root 5. And there we go. All right, one practice problem left. That was a good review of how to solve a little binomial here with a squared. Let's take a look at this last one. Again, I have a constant on one side, logs on the other, so I know at some point I'm going to have to change it to exponential. I noticed that it's addition, so when it's an addition problem, I need to make sure to multiply. And I'm multiplying the same thing each time this time. So I'm going to end up with a log base 4. This is going to become x times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is going to be another negative 7, so negative 14x. And then 7 times 7 is positive 49. So I'm going to have this whole chunk right here. X squared minus 14x plus 49 equals 1. Now, log on one side, constant on the other. I need to change it to exponential form. 4 to the first power equals this. 4 to the first power equals 4. X squared minus 14x plus 49. I'm going to minus 4 minus 4. I feel like we literally just did this problem. X squared minus 14x plus 45. So it multiplies to be 45 and adds to be negative 14. We already have these two answers. It's x with a negative 9 and x minus 5. We literally did this problem right here, okay, with these two pieces. But that doesn't mean that our answers are going to be the same. So now that we have these, we're going to add 9 to each side. If we set it equal to 0, we would add 5. So we have positive 9 and positive 5. It's literally the same. Is the original problem the same? X minus 7 plus x minus 7. What? It's literally the exact same problem. This is not a great worksheet, obviously. But what will hopefully be greater is going to be the maze. So at this point, we're ready to look over at it. So in this maze activity, you are going to start here by solving this problem. You can see you have all your properties here. You have, only a portion of them, I guess. You're going to be adding, subtracting logarithms, so you're going to need to practice rewriting them, okay? So we're going to start with each problem. You're going to solve it, and then based on what you get as your answer, you're going to go in that direction. So let's actually just do this one really quickly. This is log base 5 of 2 minus log base 5 of x plus 7 equals 1. So, because it's subtraction, I'm going to write it as a fraction. I'm going to have a log base 5 of 2 over x plus 7 equals 1. I'm actually not going to use that line. I'm going to write it now as exponential form because there's logs only on one side. So I'm going to have 5 to the first power equals 2 over x plus 7. I'm going to now the log's gone, right? Because I put it in exponential form. 5 to the first equals my of piece. And 5 to the first is just 5. So I'm going to get rid of my denominator. Remember, that's your step here. Okay, once you have that little division piece, we're going to get rid of it by timesing x plus 7 to both sides. So these cancel. I end up with 5x plus 35 over there equals just 2 here. So I'm going to minus 35 minus 35. I end up with a negative 33. I'm going to divide 5, divide 5. So negative 33 over 5 seems to be my answer, but I should double check, okay? Negative 33 divided by 5 is going to be 6.6. So when I plug it in here, this negative 6.6, it's still going to give me a positive if I add 7. So it does work. You can see, boom, negative 33 over 5 is one of my answers. I'm going to come right down here and solve this problem next. Now, if you look at the Google Classroom, I've also attached, this is the maze PDF. You can print this one out, but I also have it digitally. So let's just take a second and look at that really quick. You're still going to need to submit some work with it if you decide to do it using the slides. But what will happen is you'll come into here, you have all the exact same problems, but once you find an answer, you can actually drag whichever arrow goes with it, and that kind of gives you a little bit more of a hint. So, for example, we're going to need this, oops, not that one. Ooh, let's put that back. We're going to need this arrow right here to go from here to here, and then you can just resize it as you desire, okay? And that will kind of guide you on your way. So they have ones for each direction. Remember, you're going to be doing 13 out of these 15 problems. So if you choose to do it here digitally, then you need to solve them on Scrap so that I can see that you've done the work you need to do. And then you're just going to have all your arrows pointing to where you go. If you don't have a printer, this might be a nice way to actually do the maze and submit that image so it's quick for me to correct. Instead of just solving a bunch of problems on your sheet. Okay, so I definitely at the very least want a screenshot of this and work if you can't print out the sheet itself. So hopefully by the end of today, you're going to feel really good about solving things that have logarithmic properties involved with it. And then we'll be ready to talk about the common log and natural logs when we get together next time. Thank you, folks. Talk to you later. Bye.